Hello everyone, April 24th. Alright, let's do this. I'll do it a bit early. And we're gonna go to bed early. Tomorrow I need to wake up early and bring our cats to the vet. You're given a string S consisting of lowercase letters and integer k. We call the string T ideal if the following conditions are satisfied. T is a subsequence of S. The absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to 2. How do people even come up with questions like this? Return the length of the longest ideal string. The alphabet order is not cyclic. For example, the absolute difference in the alphabet order of A and Z is 25. Not 1. So basically it's going to be the difference between their ASCII number. Yeah. Okay, so it has to be a subsequence. So we have example of A, C, F, G, B, D, right? And in k is equal to 2, so we need to find a subsequence such that every two adjacent letters in T is less than or equal to K. Okay, so I absolutely smell DP. Okay, so maybe we can say a DP, I don't know, a DPI index is the longest subsequence, okay, of S that ends at index, right, with, no, the smaller than 2. Okay, say we have that. Now we want to find what's this DP index plus 1, right? So let's say we have this, we find the longest ending at here, so we need to find the longest ending at this. So the longest ending at this will be, we check the difference between these two. If the difference between these two is smaller or equal to k, then the answer shall be the longest ending at here plus 1, right? Because ending at here is already the longest. Actually, that is not true. That is not true. We probably need to go back to find every single one whose difference to this current is smaller or equal to k. And for everyone we need to update. Then we get the value here, the longest ending at here, which means the runtime will be k times n. And since k is small, this one will work, right? Okay, so that's not too bad. But we cannot just go one by one. We need to go from the current and down. So we need, okay, what do we need? We need an array of an array. Because I need to know where those, ooh, that's a good one. So what we need to know is the previous occurrence of the letter. What's the longest of them, right? So they can be represented by an array of length 25, right? And each one, no, length 26. And basically will represent A, B, C, all the way down. And each one will put the longest so far on there, the longest, right? Ending at, so not ending at that position, but ending at this letter was the longest. So when we, let's say when we hit B, right? What we need to know, find is previous B, right? What's the largest previous B have? And I can always plus 1. What's the largest A? And then we can plus 1. So we just search these. So we search from B down until we go beyond K. Okay, we have a solution and we can code it up. Very standard DP with a little bit twist. Just a little bit twist. Okie dokie, let's do this. What do you think? I think this is going to be a int. Okay. So I need a DP table. Right? I need a DP table. We'll call it a new s dot length. Okay, that's the DP table. And we need to know the max length on letter. That's a new int of 26. And everyone is going to be 0. That's correct, because the minimum is going to be, you can always do 1. Right? You can always do 1. Right? If k equal to 0. Right? If k is 0, then it's 1. Because there's nothing you can look for. Right? Nothing you can look for. So everything should just be 1 to start with, or if you haven't done it, that's a 0. Then we check, basically we check by itself, and then it will show up as 0. So we add 1. Yeah, it's a 0, it's fine. Okay, then we're gonna go, let's say for int I equal to oh wow, thanks.
I just want to get confirmation tomorrow. I saw I'm on the list of the tables and the seating arrangement. So I want to confirm my mom and everyone will be happy.
Oh yeah, I think.
I'll get confirmation tomorrow on
that. Fantastico. All right, so for I, blah blah blah, what do? We get the char, right? We get the char and we look through the max len order. So we say the char int current. Oh yeah, sure, for sure. Current is going to be s dot char at I, okay, minus a. Is that all lower letter? All lowercase, right? So this is the current. Now what we're gonna do is to go through for int j equal to current, j larger or equal to current minus k. Okay, this logic you need to check. Current minus k or current minus k, something else. So which means if I am something, so the distance basically is the minus, right? So A is 0, B 0, 1. So the difference between 2 is 1. And C is, so we're just gonna do the current minus K. That's correct. J minus minus, right? So we do that, and then we'll look for max length on letter. And we shall say dpi shall equal to math.maximum dpi, right? And then max len on letter j, right? And plus 1. So we go through this, and after I finish, go through this, go through everything. So I got the dp value with ending at this. What is the maximum, right? Ending at this, what is the maximum? So once we handle that, we need to say max len this current shall equal to math.max max len current and dpi, because dpi is what I got so far. And we also need, let's do int result is equal to 0. So we're gonna do, oh hi, rest shall equal to mass dot max result and dpi. Okay, so blah blah blah. Once we're done, we can return rest. All right, let's take a look. Let's take a look on this thing. Is that right? Oopsie doozy. What is wrong? Oh, yeah. So, so shall large equal to mass dot maximum 0 or this. So we can now go beyond. Hola. Okay, so it's not right. The first one is not right. Okay, something is wrong. So 4 is return. Oh, no. Should be 4. I return 3. I return 3. That is interesting. Okay, let's take a look. We have A, C, F, G, B, D, right? Okay, so the first one shall be 1. This is DP. This is our DP table. This is 1. Right, and then I'll go to C. So I shall look for from C all the way to C minus 2. C is what? 0, 1, 3, 3 minus 2, and 1. So B is C, B, A, right? C, B, A. So we say A, B, C is 0, 1, 2, and C minus 2 is 0. So we go all the way to A. So this shall be 2. Right, and then A pointing to 1, C pointing to 2, F. Oh, what is F? F shall be 1 because F minus 2, D, E, F. F minus 1 minus 2, both are 0. So F is 1. G. F, G. G is going to be 2. Right, G is 2 because G have 1, F is 1, so G shall be 2. B. Oh, I have to count up as well. My bad. Okay, that's the problem. You just, no, don't just count down. Because in this case, B, if I count down, that is just 2. Right, but B I can count up. I forgot to count up, so it should be 3. Right, and then D, A, B, C, D, count B, so yeah, this is a 4. Okay, yeah, so that's the problem. What do we do? So J shall be this plus K. Oh, okay, I got this. Mass dot minimum 25 and a current plus K. Right, because I can go 2 up, and this is mass dot maximum 0 and this. Okay, and I have confidence in this solution. We're gonna do LeetCode 2370. 2370 DP, where DPI is the length of the longest ideal string ending at SI. ON times K. Alright, do not disappoint me. 24601. There we go. Let's get this. Yes. It doesn't happen very often these days, which is quite a shame. But this is very standard. Very, very standard DP solution. We can check this. N times L, yeah. DFS. Interesting. Recursive, wait, why do you call it DFS? It is recursive DP. Bottom up DP. Space optimized. I don't even need the other one. I see. Ending at the letter. That is absolutely correct. Wow, can even be better. Okay, yeah, I see what it's trying to do. That is correct. I don't need 2 DP, so 1 is enough. 1 is enough. One DP array is sufficient. And we don't have to be this way. Just 26. And DPI is the length of the longest ideal string ending at a letter. So the same blah blah blah, and then we basically just say DPI equal DPI, and this is a DPJ. No, it's not DPI. Oh, we don't even need I for char C of S dot to char array, right? Oh, oopsie doosy. I think I remember wrong. CT this. There we go. Now we don't need this. And this is. Oh, let's call this I. C minus O. Let's call this I. J is equal to. Alright, all the current is gonna be I. And DPI, so you got a maximum DPI, DPJ plus 1. And then we don't need this. Booyah! Okay, that's much simpler. Let's do it. Let's do it. Still works. Does not work. Where do we go wrong? Okay, I is right. I plus k is right. I minus k is right. J is this. The maximum. So we are trying to get DPI. And they do DPJ plus 1. Ooh, why is this one not right? Let's see. Because I need to start with int current shall be 0. And I believe this shall be current, maximum current, and this, right? And then we shall say, DPI equal to current, and this. That shall be right. There we go. And that should be faster as well. Yep. It's faster. Okay, done with this. Good problem. All right, we have some issue yesterday, and let's debug it. We haven't submitted yet because we have issue with the first one. Okay, let's debug this. No. What's the result of this one? Output should be 6. Okay, and what's the input? I don't know what's the input. Receiver and K. Okay, receiver, K. Get receiver and K. Okay, where do you put? Good question. Build cycles. I will let build cycles pass. I will start from compute maximum score. How about that? We'll compute maximum score. And we'll put it. Okay, let's just put maybe put it here. No, 5. All right. Oh my. Thread stopped. I can't even go through this thing. Okay, so yep. That was very wrong. Okay, so let's undo this and put it inside here. Okay, let's do this. All right, we are trying to build the index, so we start with 0. What is the thing that we're doing? 1 1 1 something, right? We're doing this 1 1 1 2 3. So we start at 0, okay? And then current cycle is a deck. No cycles. Receiver current logic is 0. Yes. Current cycle, we add a current. Which index we add 0. Yes. Next is going to be 1. Yes. Receiver 0 becomes -1. Current becomes 1. That's true. Append 1. Which index? Oh, that is the problem. No, that's right. That's right. Which index is inside the current? So index is 1. Next is 1 again. Receiver current. So that becomes -1. Current is still 1. Boom, get out. Which cycle current? Current, get out. So current is 1. If which cycle current is larger or equal to 0, which cycle current is not? So we say cycle.append current cycle and which index current is 1, which is 1, so cycles append. So cycles now have cycles now have deck is this, and the length of cycle is 1, 0 to 1, 1, 1, 1, 1. Okay. So build cycle. If receiver I is 1 is larger or equal to 0, no. 2, yes. Okay, now index equal to 2. Okay, we go in. So current is 2. Receiver, this is larger equal to yes. Cycle.append current. Okay. Which index? So that is going to be 0. Next is 1. And the receiver, that becomes -1. Current equal to 1. Jump out. Which cycle current? Which cycle current? Which cycle current? Oh. Which cycle? I think it's because you forgot to say which cycle. Yeah, you cycled out a pen, but you didn't say which cycle they belong to. You have to do which cycle when they all belong to, right? If which cycle current larger than 0, then you say you do this, you put it in, and then you do this. But here, cycles.append this, and you should say for I in range no, we should say for element in current cycle, right? For everything in the current cycle. Yeah, why do you do it this way? Hold on, but let's do this first. Element in the current cycle. So each one we should say which cycle element shall equal to length cycles minus 1. And here, can we just do for element in current cycle minus 1? Oh, I can't because it's not. Wait, hold a second. Why we cannot do it? Because you can. Wait, hold on. Really, you cannot for element in current cycle this. Cycles element 0 dot append left element, and then which cycle element equal to which cycle current. Current cycle int is not iterable. How is int? Current cycle is not int. Really? Maybe we just cannot do that. I don't know. Sequence index must be integers, not slice. I think I know why. Yeah, it's because it's a deck. Yep, So since it's a deck, we really cannot do much. But I can iterate this way. Ugh, we're still wrong. Should be 6, but I got 9. But it's a different error, okay? It's a different error. So what I'm gonna do is, hold on. I don't need this. I'm gonna put, let's put it here. Save this and 5. Okay, so now we want to know is the cycles. Okay, cycles. Cycles will have 0. Okay, cycles we have 0. And that's it. And we have 2 element, right? A cycle at 2 element. 43201. 43201, yes, because if you start from 4, it goes to 1, start from, and the length is 1. Okay, yeah, this is correct. And then we need to try to compute. What's k? K is 3, so you do this, which is 9. Oh. Four, 3, 2. There's no 4, 3, 2. These are positions. These are freaking positions. Now you have an issue, because I don't know the actual value. Right? Because you start from 4. You start from 4. Then you go to 3. Then you go to 2. Oh, wait, hold on. The answer for this is 10. My bad. The answer is 10. I got it wrong. The answer is 10, not 6. The answer is 10. Okay, do we have to rerun it? Yeah, we probably should rerun it. Let's go rerun it. Okay, so the answer is 10. So shall be 4, 3. So 4. 1, 2, 3. Yep. I only get 9. Because you go 4. We'll go to 3. You go to here. Go to 2. How come it's 0 though? Right? How come it's 0? That's the question. So you build 0, 1, 2, 3, 4 of 1, 1, 1, 2, 3. Right? You hit this 0. You go to 1. Then you go back to 1. Then you go to 2. You go to 1. 1 doesn't go. You go to 2. Okay? And 2 go to 1. So basically 2 need to do this. Yeah. You don't append to this. Oh, shoot. It is a cycle, but you need to point directly to this. Oh, that is correct. Yep, you should point directly to this, but then how do we do that? You need to create a copy of the cycle. I feel like I need linked list because I have 2 pointing to this. And of course, we don't need a linked list. We can just use a tuple, right? We can use a tuple. So this to point into this. We can do a tuple of value and next. But then, yeah, then you just need a root. But then, you know, how do you know which cycle you're in? Right? You don't know which cycle you're in. Holy crap. But wait a second. Wait a second. I do know, right? Because this is... Hold on. Yeah, the problem is, if you do linked list, how do you find the end? You know, with an array, you can do that. Well, with a linked list, I can put the back to the front, so I can naturally have the cycle. Okay, that is fine. But how do we... Because the ultimate goal is I'll go through each list, right? I'll go through each list. Damn. Yeah, I need to know if it's... So it's not even at the beginning of the... it's not at the beginning of the... How do you know if you're in the beginning? You don't, right? You go to this and it says that index has been visited before, right? You don't know where to append yourself to it. Yeah, like technically you should create a new, but then you'll have to copy the entire thing. Right? You have to copy the entire thing. No, I don't think that will work. We should not copy anything. But if you do linked list, I can do a simple linked list, right? If you do linked list, we can assign the elements, the node, to each position. Okay? That is fine for each position I have. But the issue with that is once we build all the cycles, right? Now what? Because the goal is we go through the very beginning. So who is the head, right? We just need to know the head. We just need to know the head. A doubly linked list. Doubly linked list. So now I know the head. The head, I can record the head. Record the head. A set, right? I record the head. I remove the previous head. I add the current head. So after that, I'll have a bunch of head. Then I start from each head, okay? Then what? then I need to go, but how do I know the length of the cycle? How do I know the length of the cycle? Length of the cycle. Because as you go, boom, you hit back, right? Boom, you hit back. Then we say if the length has not been, this cycle, and then what you do is you go through every single one, because it's double linked list, so you go through every single one, and you put the length there. Right, you put the length there. So if you have a length, we know it is inside the cycle. So you go through everything, you put it in there, okay? And then anything else is just always connecting to the outside, so it doesn't even have a cycle. Okay, so now we have something like this. We have a value, a previous, a next, and cycle length. Right? We have a cycle length like that. We have 4 elements in this. And then once we have that, we'll get to... No, everyone should have the cycle length. Everyone will have the cycle length. It's just a recording of what this is. Or we can put the cycle length just for the front. But it's okay. We just need to keep this at every single one of them. Because otherwise, how do you know? Right? Otherwise, how do you know? You don't know. Right? You don't know. Yeah. So now we have the cycle length. Then, when we go from the head, right? Now we go from the head. How do you know the total length of this thing? Oh, the total length. Total length. Okay. How about we... We always start from the end of the cycle. We give it an index. Okay, and as we go back, we increment the index. Okay, so now everything has an index, right? Everything has an index. In the linked list, everyone has an index. Then how do we know where the cycle starts? Shit. So as we go through, you can't just freely access. Yeah, I have to think about this. Linked list can solve the issue of cycles, of like multiple point in the same cycle. Linked list can solve that, but what it cannot solve is how do I randomly access a value? Because I need to compute, right? I start from the front. I need to get in. How do I do that? Maybe we don't use linked list. Maybe it's fine. Okay. So we find the first one. Okay. And then we find a new thing. If they're connecting to that, we record where they connect. We do, we do a small chunk and we note where they connect, right? Yeah, we say where they connect. Okay, so this is like another semi-cycle. It's not a cycle, it's just a piece, right? It's just a piece, and the piece need to connect to something. And we'll go through the one that is a cycle, okay? We go through one that is a cycle, and then I'll do everything that I just did, right? Everything that I just did. And I have the value for every single one. So from here, what is the biggest? From here, what is the biggest? No, from here, what's the k? And then record that. And then from the piece that is not a cycle, but connected to one of them, I will pick that out, right? I'll pick that out and then continue there to find them. Okay. That might work, but we have to make big changes to this. All right. Definitely not for today. I'll end it for now. And, well, see if we have some time tomorrow to go back to work on this. Yeah, this is... I'm 100% sure that this is not the right solution, but I want to continue with this because I think it might work. Well, I thought this one will work, but I didn't realize about this bug. No, this bug. But the current one, I think will work. What is this tomorrow?